Today we're going to talk about removable discontinuities. Alright, so the first thing that we have to keep in mind is what is a discontinuity? What does it mean to be discontinuous at a point? Removable discontinuities are also referred to as holes in the graph. That's how you might recognize them. Alright, so removable discontinuity creates a hole in our function, the graph of our function. And it's a point that we can't have. It's a point that's excluded from the domain. Alright, that's just kind of the definition of a discontinuity, but it's a point that's excluded from the domain. With that, let's look at an example that'll kind of make it more clear. So first, say we have the function f of x equals x squared minus 2x minus 3 over x plus 1. So let's say we're working with this guy. Our first step here is going to be factoring. So we're going to start by factoring that numerator. So when we do that, I'll do that off on the right hand side here, x squared minus 2x minus 3. We say what multiplies to give us our last term, that's negative 3. So what multiplies to negative 3 and adds to our middle term. So what two factors add to negative 2 and multiply to give us negative 3? The answer to that, of course, is going to be negative 3 and positive 1. So when we factor that, we're left with x minus 3, x plus 1. So we can replace our numerator with x minus 3x plus 1. So we'll go ahead and do that. Once we've done that, lo and behold, we have a common factor in our numerator and our denominator. So we get to say, get out of town, x plus 1. All right. That's the removable part of removable discontinuity. All right, so when we get to say get out of town, that's the removable part because we're taking it out. The reason that we care about that point though is because if we look at our original function, we can't have this denominator equal to 0, right? We can't divide by 0. So denominator cannot equal 0. So even though we took it out, we still have to account for it. So I'll go ahead and do that. X plus 1 cannot equal 0, right? So if we solve for that, we'll get the x value of our removable discontinuity, which would be negative 1. All right, if we put that back into our simplified function, we'll figure out what the y value is for that hole. All right, so we put that negative 1 into our simplified function, and we get negative 4. All right, so our removable discontinuity, which I'm just going to call RD, is at negative 1, negative 4. Maybe it'll help though if we illustrate that with a graph. So let's just pull up a graph here on the left hand side. Just a quick sketch. So we're sketching our simplified function, which is just x minus 3. All right, as you all know from algebra and pre-alg and alg 2, we start at negative 3. So I'm going to go down 3. All right, and then my slope is 1, so I'm going to go right 1, up 1. And then I have my hole at -1, -4. Alright, not a perfect sketch, but I'd say a valiant attempt. Alright. Important thing here is we have a removable discontinuity. At -1, -4. Alright, and we've got the basic sketch of our line, which is starting at -3 and has a slope of 1. My x-intercept here is a little off, but let's just say that's it. So this is 3 where it intersects. Sorry about that. That's all for now. We'll practice removable discontinuities quite a bit in the future, so thank you.